students, this is our last, if I'm not mistaken, the last part of Euclidean geometry, I think. It looks like we've got consolidation and exercise afterwards. So, yeah, after that's analytical geometry, which is much more pleasant. So, we're going to learn today about midpoint theorem and its converse. Okay, I'll explain what that converse means later. So, it works with triangle. Okay, so imagine we've got this triangle, A, B, C. And we've got a line that connects D and E. Okay? Now, AD equal to BD and AE equal to EC. So you can see that DE line kind of bisect both these sides. You know, I'm just going to pause here for a second. Let's just, hopefully that's better. So we've got this line, so AD halves this side and that side. Okay? If that is the case, if you ever come across a triangle like that, you can use the midpoint theorem to simply say that then DE must be parallel to BC, and it's half of it. So in other words, if this is 4, this must be 2. Okay, that's the midpoint theorem. Does that make sense? Are we happy with that? Okay, let's pause here for a second. So the converse of the midpoint theorem, not exactly converse, but it's maybe another version of converse of the midpoint theorem, starts slightly different. Let's say, again, I've got a triangle, and I know that, yes, AD equal to BD, so this line, DE halves line AB. I don't know anything about AE and EC. I don't know that they're equal to each other. What I do know here, that these two lines are parallel. So if these are equal to each other, and these are parallel, that tells me that AE is going to be equal to EC, and again, DE will be equal to half BC. Okay, so I'm starting with a bit different data every time, and I'm getting different results. Here I knew that this is equal to that, that is equal to that, and therefore these lines are parallel, and this is half of that. Here I just know that one side is equal to the other, and I know that these two lines are parallel, right, D equal to BC, and in this case I can assume, or I can use the midpoint theorem, or more precisely I should write midpoint theorem converse, or converse of midpoint theorem, to say that A equal to EC and DE is equal to half BC. Okay? That's the midpoint, and that's the converse. Okay? Now, we're going to solve a question, one question on this video in a minute. But just to give you, to know what's coming next lesson, I'm going to prove to you the converse. I'm going to actually prove to you how we can tell the converse midpoint. Okay? Right? And you can see now.
I got contact now.
Contact. Okay. Right. Okay, guys. So next lesson, I'm going to prove to you the converse theorem. This one I'm not going to prove to you now, but in grade 12 you're going to learn how to prove that. Okay, so you don't have to worry about proving that right now. Okay. Pause here. So just to confirm, there was a question, James. Here. We don't need to prove the midpoint theorem now. We need to prove the converse, which we'll do next lesson. We don't need to prove the midpoint theorem, but we still need to use it. So now we're going to do a question where we're using it. So we've got this triangle. We are told that AB equal BC. It's a good idea always to make notes on your diagram as you go along. Okay, so AB equal BC. GE is 15, so I'm going to write 15 here. AF equal FE equal ED. Okay? Now straight away, I don't know about you, but you can see a couple of triangles. There's the big triangle, but actually that's not what I need. I've got this triangle, ACE, which you can easily see its midpoint theorem, right? This is equal to that, that is equal to that. And then you've got the small triangle, DFB, where you have, again, those two sides are equal. This is 15. I don't know anything about that. But if I knew that I could use midpoint theorem and this is 15, then what do I actually ask to calculate? They asked me to calculate CE. CE. So they asked me to calculate CE. Okay? So I know if I could use midpoint theorem, if this is 15, then maybe that will be 30. And if that is 30, then in this triangle, this whole thing is going to be 60, isn't it? It's going to be double. But I need to be able to show that it qualifies for the midpoint theorem. So Watch how it goes, okay? So first of all, on this triangle, okay, in triangle ACE, okay, I can see that AB is equal to BC and AF equal FE, and it's given. Both of these are just given, okay? So you're looking at triangle ACE. Now, the midpoint theorem tells you that BF, therefore, BF is parallel to CE. Okay? Right? Because these two sides are equal, these two sides are equal, that means that BF is equal or parallel to CE, and the reason we give is just midpoint theorem. Yep.
Isn't it,
I'm just going to pause here for a second. Okay, so just a small correction, of course, that should have been FE, not FG. I wrote FG, but it should be FE. So now I know these two lines are parallel. Now, if these two lines are parallel, then obviously GE is parallel to BF. Okay? If this is parallel to that, then obviously part of that line will be parallel to that line. Okay? And you can see where I'm going now. Okay? I know that FE is also equal. So now I'm going to look at triangle, the small triangle, DBF. Okay? DBF. Now, what do I know about this triangle? Well, first of all, I know that's, well, I just know that one. I'll write it again. Okay? Maybe you don't have to, but I'll just write it. GE is parallel to BF. Proven. Okay? Probably don't need to repeat it, but let's just do it. And then the other thing I know is that FE is equal to ED. That's given. Okay? So now I can invoke the converse of midpoint theorem, which tells us if we have two lines that are parallel, and this side is equal to that side, what does it tell us? What can we say now?
GE is half of BF.
That GE is half of BF. You're right. It tells us that, or I can even say like this, BF is 2 times GE. I'm writing the same thing, but instead of half, I just doubled it. You see what I've done here? Okay? And I know that GE is 15, so BF is therefore 30. And the reason I need to get is midpoint theorem. And I really should say converse. I don't know how strict they are here, but I should really say converse. Okay? So now I know that this is 30. And now what should I do? I'll just pause here, see what you guys are going to tell me. So now I know that BF is 30. I'm going to go back again in this triangle, triangle ACE. Now, you don't have to write every time like I do in triangle ACE. I'm really doing it more for you now so you can zone in on the triangle that you need to zone in, because there's so many of them. Okay, so in that triangle, I know that CE is equal double 2 times BF. Right? Because if BF is half of CE, then C is 2 times BF. And I know that BF is 30, so 2 times 30 is 60, and the reason is midpoint theorem. Okay? Right? So, it's not difficult. I mean, the theorem itself is not difficult, but you can see there's lots of triangles inside out, and you just need to just get a feeling of what to look for. I'll pause here. Well, I'll end here, and now to you.